Hello, everybody, and welcome to Handmade Hero. We are back. I wanted to take a look at some collision detection stuff today because we just did collision detection over the past couple weekends, and we are at the point where we have to. So, I'm actually pretty. I guess I haven't run the shell.bat here. There we go. We actually haven't looked at one aspect of collision detection. We did some kind of interesting stuff with it, and you can sort of see if I go ahead here and run the actual game. What you can see is we actually had some reasonable collision detection stuff working. You can see here that like I can now move the glove around, and it's kind of on a very loose spring right now. Which is probably not great. Like, we probably don't want it to be on that indefinitely. But what you can see here is that, like, it works pretty solid now. The glove doesn't really get stuck in things, and it's pretty good in terms of collision detection. So far, we can sort of get it like lodged on the other side of stuff usually, and whatever. Like, trees currently don't have collision detection. You can see that there's no collider on trees, which is probably something we have to fix because we probably don't want the glove going through trees, I would assume. But anyway, you can kind of see that it works pretty good and it doesn't really have a problem. But we do have some issues with it that we'd like to address. And the issues, well, they're not really issues. They're just things we haven't implemented yet, I guess is the way to look at it. And there's a couple of them. So number one is that we don't have a way for something to get unstuck if it's created in a stuck position. So I think we're doing a pretty good job right now of not getting something stuck. It can get stuck in the sense that, like, when it's trying to move. Let me parse all these out. So things are currently squares or right rectangular prisms, right? And the problem is, so you can get stuff like this, for example. So that's not stuck. It's just, it's trying to move straight and it can't, right? So for things like the glove, we want to probably switch to a sphere so that it will roll off of surfaces, right? Because, like, there's no amount, like, if you zoom in on what's happening here, right? There's no amount of moving in this direction that will ever cause that thing to move forward. It will always hit this thing, right? So you have to move it sideways first before it could move forward. So it's not stuck in any kind of numerical sense. If I just hop, ooh, the heck happened there? Why is my camera, that was weird. My, like, debug camera shot to the side. Oh, because he moved over a threshold. Yeah, all right. The debug camera is its own thing. All right. So let me switch back to regular camera so you can see. So you can see here the glove can't move forward, right? Because it's pushing against a block, but it's not stuck. If I move over here, it can come out just nicely, right? So one thing that we want to do that has nothing to do with the numerical quality of the collision detector is we'd like to switch, like, at least the glove, but probably enemies as well, to using something like a sphere or a cylinder. So that it can sort of smoothly roll off of things easily, which just feels better to the player usually. The reason we do this in games, the reason we use cylinders or capsules or spheres is specifically for that feel. It just feels better. Regardless of what the actual shape of the object is, the player would rather feel it smoothly roll off of things rather than sort of the stuck nature that you get with right angles where they can't glide off of each other, right? So anyway, what we want to do is A, look at that, but B, that's just adding a collision type to our system, which is sphere, which wouldn't be that hard. We were already set up for that. But what we don't have is any way of getting unstuck if you are created stuck. And at the moment anyway, I guess I don't know if we have any test examples of this, meaning an object that is stuck in geometry when it is created. I just feel like we want to support things like that because they create bad situations in game design where if you accidentally screw up the game code and piece of game code accidentally creates an object, which is easy for it to do if it doesn't have really advanced placement logic or something, if it accidentally creates two objects interpenetrating, we don't have code that would really, at this point, allow those things to become unstuck, right? There's a little bit of a way that things can become unstuck currently, and right now, there's not much of that, right? So there's two things. There's the one that's getting stuck, like this glove can get stuck in between or on things. Again, not stuck in the numerical sense, but you can see it can kind of get pinned between things or trying to move in a direction that it simply can't, and it won't really roll around on it. So that's one thing we'd like to fix. Similarly, like you can see in this particular case, right, it's wedged between two things at least, and can't necessarily get out. So we have like all sorts of things like that we would want to fix with spheres potentially, or where we have so I can't really demonstrate this one. I mean, I can sort of demonstrate it like there. That's good. Probably. I'm trying to see if this actually is true or not. Yeah. Okay, cool. So the other thing we've got is, so in this example, right, this is a perfect example of the second thing I'm talking about. That is an actual, it's not a numerical problem, I suppose, but it's an algorithmic thing we want to fix. So this rectangle here, right, that's attached to the player is moved mandatorily on every frame, meaning the collision system doesn't get to reject movements of it. So what has happened here is it has placed itself directly on top of the glove's bounding box, right? Now, this is not a big deal in practice because, hey, the player can just move or something and that will unstick the glove, but we don't really want that to be the feel, right? And similarly, this is exactly the kind of thing that would happen as well in a situation where two things were created overlapping. So in other words, once two things are overlapping, some system that has nothing to do with collision, so it's not a numerical error, but just some system such as the mandatory player movement system places two things overlapping like this, it then locks up the collision moved one because it's like there's nowhere it can feel to go that isn't also colliding, right? And so the reason I say we want to handle that is because I don't actually want to have to care about that. I don't want the rest of the game code to have to consciously avoid this problem. I don't want to have to put things under physics control to avoid this or anything like that. I want to be able to keep doing what I'm doing, which is just hard moving the player wherever I want, and then having the collision detection have the slop in it as necessary to unstick those. And so I have it to do in the code, and that's the one I want to look at today. Before we add like spheres or whatever, I want to add a thing that basically says, if you started the frame intersecting, then we will let you try to get out of that intersection, right? And this is a little bit difficult. It's a little bit difficult because I don't know that we have particularly good ways of concretely measuring your separation directions necessarily, but we probably can invent some. So that's probably not the hugest deal in the world. But other than that, it doesn't seem like it'll be that hard, and the reason is because we already know that we're in this case. So it's not like this is a mysterious thing that we're not aware of. We literally know that this is the case because if we test the original starting configuration for intersection, we will get back true. Like, we will get back the fact that it is in this thing. And so it's easy for us to take action based on this scenario, specifically because this scenario itself is easily detectable, right? So that's what we want to start taking a look at today. Okay. So as you can see from this configuration, right, I can move the glove target. That's that little white thing there, right? I can move the glove target around, and it's kind of crappy. Like the glove target, we have to work on our glove movement code. That's going to be a big thing we do. But we wanted to get the collision detector solid first because obviously that's a big part of it. But either way, you can see, like, I try to move it here and it can't get out, right? It can't figure out how to get out. Now, one of the directions, that direction, it probably shouldn't be able to go in because that would require it moving through that object. But another direction, intuitively speaking, like that direction, we probably do want to be able to go in because it's just sort of unfortunately overlapping based on the movement of the player. The player kind of stomped over it and is now overlapping it, and we would like to have it now so that it can get out of that situation, right? We'd like it to be able to move out because that's the least moving out in that direction is the least amount of motion to get it unstuck, right? So if we look at the way the collision detector currently works, what you can see here is that it's pretty straightforward, right? You can kind of see like how we've got it going. There's a pretty straightforward to-do here, handle getting unembedded. That is the to-do we want to do today. And you can kind of see here the way that the algorithm works. What it does is, for those of you who haven't watched the entire collision detection series where we're doing it, is we use sort of a voxel model where we say, let's test the squares in a aligned voxel around where this thing is. Let's see if any of the corners of it would allow it to be placed there. And then based on that, what we do is we allow it to move out of that voxel into a neighboring voxel if the corners of the voxel in that direction would indicate that that move is legal. And that's what these 4 things are doing here. They test the 4 directions that you could move in a voxel that go towards your target. So if you think about a voxel cell is a cube, right? There are, depending on how you want to look at it, there are 8 vertices of the cube, 6 faces of the cube. If we pick a direction to go in, then there are at most 4 different voxel cells you could imagine going into in that direction. The one that goes out the 3 faces. So, let's suppose our direction is, you look at the sign of the direction, you get like positive, positive, negative, right? So positive X direction, positive Y direction, negative Z direction or something is the vector of motion. So then we would look at the positive X face, the positive Y face, and the negative Z face, right? We'd look at moving into the cells on those sides, and then we would also take that vertex, the vertex shared by those faces, and try to move into that. Now, there are other things we could do there. We could look at more cells. There's a bunch of things we can do, but that seems to be a pretty reliable set of choices, and then we just take whichever voxel cell produced the closest point to the target, and we move into that one. Now, another thing we could do is consider this more of a search and go propagate that search out. We're not doing that right now. We just propagate always just to closest. You could think of this sort of as like an A-star search without the search. So just always going to the closest thing, never backtracking when we then hit the end of as far as we can go. So this might be fine, and this might be all we want, but like I said, so now, and I'm pretty pleased with how it's working. It seems pretty stable and good to me. And when you look at its performance, so far I really have never seen it get stuck on something that itself wasn't placed on top of it. And if you can place something on top of it, then obviously it will get stuck because, like I said, everything at that point is colliding. So it seems pretty robust and good. We haven't done like extensive attempts to validate it yet, so don't want to say anything prematurely, but it seems pretty good. So what we really want to do now is look at how we would modify this routine because it's written with the assumption that if we did this, for example, where we checked collision at the start, it's assuming a priori that we would not be in a cell that was completely embedded. Okay. Now, I don't think we really need this. We don't care about this. It's not relevant. We want to do, and this is a little bit of collision detection philosophy here. Collision detection is something I've done a lot of work on in the past, so I have a philosophy about it as opposed to things I don't work on a lot, in which case I don't have a philosophy about it. In my opinion, when you're doing collision detection work, one of the biggest things that you want to do to keep them robust is you always want to test the same thing every frame. So what you really don't want to do is introduce a lot of things that vary based on the person's position, right? The cells themselves want to be aligned to the world, so they're consistent. And you typically want to test things on the cell, not the individual things, because the more you can keep things regular, the less room there is for weird error to sneak in based on the specific locations of things. And so it helps keep things reversible. In this particular case, because we know we have a game where we're cold setting the position of stuff just in game code, it's less important because we know that we'll be getting those bad situations because the game code will just produce them. And there's nothing we can do about that, no matter how precise our code is. But again, philosophically speaking, I approach this kind of code usually by saying, I feel like my life will be easier if, in general, I minimize the number of things that can be different from frame to frame. And using a coherent testing methodology where the points that get tested are the same all the time can help with that a little bit, right? So anyway, so I'm going to get rid of this because that's what we're working on now, and I don't want to do those things. What I'd like to do is focus more on this scenario. So one thing that I would like to observe about this code as it exists at the immediate moment is if you take a look at how the voxel occupation code works here, where we compute the occupiers for a voxel, what you can see is because you are only allowed to move out of a voxel if the occupation criteria for that voxel says that you can, it means that like I would argue that therefore there should be no way for us to be in a voxel where we are not colliding on some of the points, and then we move to a voxel where we are colliding on all the points. The reason for that is because each voxel shares at least one point with all neighboring voxels, right? In the case of moving through a face, we know that we share 4 points. In the case of moving through a vertex, we know that we share 1 point. So if we are in a voxel and we look in a direction and we say there are points that are occupiable in that direction, we know that then the voxel that we move to cannot have all 8 points occupied. If it could, then that means one of that we shouldn't have seen any unoccupied points on that face, right? So to me, that means that we have a sort of nice ancillary thing here, which is that if we take a look at these results here, so this occupied stuff, and I'm going to write this in the sloppiest possible way. We could just be summing these with a counter, for example, and avoid all of these. But we're not even a little bit concerned with the performance of this routine right now at all. This is not a performance-oriented piece of code yet. We're literally just doing it just for correctness first, like so. And so all I'm going to do here is say that there's an embedded, and I look and I see, look, oops, that's not an or, that's supposed to be an and. Wrong Boolean operator. So I'm just trying to see, look, if all of the points of this voxel are all occupied, then that means that I have embedded, this object that I'm looking at is completely embedded, right? It can't get out. And so what I'd like to do here is I'd like to have some way of determining a motion that I can do. And you can see here, is essentially what I'm doing is I'm saying, hey, I'm going to determine whether I'm embedded. If I'm, these are on the wrong side of the branch. There we go. A bit of a slow morning. There you go. If I'm not embedded, then this is probably okay. And the reason that this is probably okay is because if I'm not embedded, then I'm by definition not stuck in anything. So I should just do my regular series of moves, because if I can't do them, that just means that the player or whoever is controlling the motion of this object is trying to push through something that they're not allowed to go through, and I should just not let them, right? Meaning either this will succeed and the object will move somewhere, or it will fail, and that's what should have happened, because the only valid movement is in the opposite direction from where it's looking, and therefore we should prevent it because it's trying to push through a solid object, and that's not allowed, right? So we want this to happen anytime we started off in a place where there were unoccupied vertices of the voxel, but in the case where all of the vertices were occupied, we know that we've effectively gotten ourselves into a situation where we're embedded in another object. So what we need now is a solution to this problem. We need a way of moving from this voxel to another voxel that doesn't have that, what's the word I'm looking for? That doesn't have that problem. Okay, so couple of things about this. Obviously, there are limits to what this probably should or could correct. And we have to think a little bit about how forgiving we want this to be. We could make it extraordinarily forgiving, which says that if you're embedded in something, you can just go wherever you want, right? And for example, just to give you some perspective on what that would look like, I could literally just say, if you're embedded, you get free motion. And then I'm going to tell you why I don't want to do that. But obviously, that's one quote-unquote solution to this problem. Now, remember, I held the game open here. It's still running. We're in this kind of state here, right? And now I'm going to compile it. And then so it's going to reload in the middle of the code here. I don't know why there's a breakpoint set there, but there was. And now what you can see is I'm unstuck. Right? And that's exactly what we'd expected, because now it's allowed to move out of there. And I'm pretty sure that this would just work. I don't think that was a very complicated scheme there, but you can see, like pretty much now, anytime this thing got stuck in the middle of something, it will just get unstuck. It probably just did it just then, for example, and so on, right? Now, the reason I don't really want to do that is because I believe this would create a little bit too much opportunity for speedrunners. Again, because we know we have this sort of scenario of there's these things like the player's head that gets moved or like these things, right, that get moved programmatically that aren't subject to physics. They're literally, they hop from square to square with gameplay logic that's required. Sort of a hybrid. We have a hybrid engine, right? Some of things want to be on mandatory game logic. It has to go from here to here. It's required. We check occupancy. We only allow one thing per square for gameplay rule reasons. Kind of not that dissimilar from John Sokoban game, right? There's a transactional move system underlying this game that means that things that aren't projectile or floaty, they move with a rigorous game logic that cannot be broken. It has to go the way it goes. But floaty things like the glove, it's a hybrid because they are built on a physics thing and they can physics themselves around. But we could change that, right? I mean, another thing we could do is say, no, let's not do that, and let's actually make these things transactionally occupy squares. You know, that's probably smarter. Who knows? But we don't do things smart here on Handmade Hero. We do things just to have an excuse to do different kinds of programming so people can see how to do it, right? And so that's what we did. And you can see how cool this collision detection system is. It's so darn good, right? It just hugs the wall that whole way. It does, like, look at how smooth that is. It's very good. So pleased with it's such a small, simple routine. You saw how simple that routine was. Produces excellent results. Really very happy with it. Anyway, so when we look at this, what I was thinking is like, suppose I do that. Now the collision system knows that it has like effectively two pieces, and I guess I didn't do a very good job here, so it kind of snuck underneath, so it didn't happen. But I feel like it wouldn't be that hard for me to push the glove into the wall, especially using something else. And the speedrunners will find anything, right? I mean, they'll find everything. I feel like there's like that, right? So did you see how I kind of was able to push that into the wall? And it's because it was up high, and then the blocker pushes it into the wall. And now it's embedded in the wall. And once it's embedded in the wall, because my rule is if you're embedded in the wall, you can do whatever you want, you can see I can just move straight through the wall now, right? If I rerun the game, because it's hard to see with the camera in there because there's stuff in the front. If I rerun the game, so you can see it in there. Do you see what I've done? Now the glove gets to move all through that region. Again, not a bug. It's literally what I told it was supposed to be able to do when it was embedded. So you can kind of see why I don't want that specifically. And the reason that I don't want that is because I don't like the idea of speedrunners having quite that much ability to screw with the game's collision rules, right? Because at that point, they can do all sorts of, like, intentionally embed something into a wall because they know that the collision detection will be forgiving, and then they'll use that, right? And, a part of me just says, like, just do that anyway because speedrunning is cool, and you want to give speedrunners a bunch of cool things to do because it's just cool, right? So believe me, I'm sympathetic to the idea that maybe we should just do it that way, but on the other hand, I'm like, it's a little too much. I feel like we yes, give them some things to work with, but that's a little too much in my book. So I'm not comfortable with that level of a gimme to speedrunners. So, what I want to do instead is I want to do something where if we're embedded, we create, for example, maybe a new motion vector, and that motion vector is based on some kind of displacement that would try to get things unembedded in a way that we hope will be reasonable. There's a bunch of risk involved in doing it this way, to be sure, but I want to give it a try. So let me motivate this for you a little bit, just so you can kind of have a little bit of an idea about what I'm talking about. So if you take a look at how this is working here, you can see that what we're planning on doing here is we're detecting embedded by saying here's the 8 vertices of the voxel cell that the player currently finds himself in. We know that they're all occupied, so we know that in order to move the player, well, I shouldn't say player, the entity, like the glove in this case, will have to go in some direction that is clearly not indicated by its occupied status, but allowing it to move in whatever direction it wants to move is probably too permissive. What we'd rather do is only allow it to move in a direction that would get it less embedded, right? Like we want to produce some idea of the direction of motion that is moving out of the embedding that this entity has found itself in, right? Now, the most straightforward way to do this would be if we were to take the position of the entity and try to come up with a unembedding direction from there. And the reason I don't want to do that is because since we're basing our decision about whether or not you can move on vertices of a voxel, if I then say, well, we're going to base our direction of how you get unembedded based on your actual position, we run the risk of your actual position not colliding, whereas the vertices of the voxel do collide, right? And I realize that that's kind of a bit weird because, in theory, you'd be like, well, wait, how the heck could that happen, right? But numerical precision-wise, it certainly could. If you imagine the voxel cell, maybe you can stand just like all of the colliders are just such that if you were to stand on any of the vertices of the cell, you would be intersecting the ones on like the left side or the right side. If you stand on the left side, you'll intersect the left side ones, the right side, but right in the middle, you could actually stand there. And the player or the entity happens to be right in the middle, right? So one of the things that's a little annoying about this is I would like to be able to just test one position, but I really can't quite do that because in order to do that, I would actually need to know that they were themselves embedded, which they might not be. So I need to be able to produce a motion vector that hopes to get me unembedded based on something else. Now, the easiest way to do this is just to produce that motion vector for each of the voxel positions. And if I did that, and then I just kind of I could trilinearly interpolate it. I could just use the average of it. I mean, really there's all sorts of things. Most of them will just work fine, except for the fact that they probably all have some bad case where you could imagine them not producing a vector that will actually get you unstuck very effectively, right? So I can't say that there's anything that I'm coming up with magical here in my head. It just kind of seems like probably, I mean, I'm tempted to just wing it and say, look, we'll do one of those and we'll see how bad it is. I don't know how rigorous we want to be about this particular thing. Like, I don't know how much validation we want to try and do here and say how bad of situation should this thing be able to recover from. And I don't know. I don't know the answer to that question. But either way, I'm pretty sure that I'm going to want, I'm pretty sure I know what I'm going to want here. In terms of sort of like basic routines anyway. So I think I'm just going to go ahead and write those and then we'll see. So if you look at like collides at P, for example, really what I want to do is modify this collides at P function to produce more than just the fact that it collided or not. And what I want to do is produce sort of a repulsion field, if you will, right? So when I'm looking at collision, anything that this collides with, I want it to produce a repulsion field that basically says, look, we're going to push you away from this thing if you're embedded in it, right? And maybe I even want that repulsion field, it's just hard to say, but maybe I even want that repulsion field to reflect how far embedded into something you are. So if you get more embedded into something, it tries to push you out of it harder than if you were less embedded in it. And the reason that I'm saying that is not because the actual code on the outside will push you any harder, because it's literally just talking about a move from a voxel to a neighboring voxel, so it's not trying to push you with any particular amount of force, high or low. It's just a basic movement. It's not affecting your velocity. It's not affecting anything. However, what I'm actually talking about when I talk about that amount of push, what I mean is that we are going to be looking at situations where, because any time that you are embedded in something, you don't have to just be embedded in one thing. For a very simple example, if I go back to the game here and you look at some place, let's say that you embedded yourself right in this area right here. Well, there's 1, 2, 3, 4 at the very minimum. There's 4 separate like colliders that you could have embedded into, right? And so if you embedded very far into these two, but not very far into these two, so pretty far to the left, but not very far down, right? Then you may want the resulting push, like the direction that the thing is saying you should go in, you may want that to reflect a more rightward push and a less upward push, just so the outer routine knows it's trying to get things further to the right than it is trying to get them up, right? So it's more about producing a vector that captures the direction we're trying to go to disembed things. So it's more about that and not so much about how hard the outer routine will actually try to move you, because it's not really about that at all, right? And again, I really just don't have a strong opinion about that off the bat. I'm not sure I can really think of much that's important there, so it's just a little bit hard to really consider. So I don't know yet. But anyway, I am probably going to do a little struct here that we're going to say, like, I'm going to call this a collision field, maybe. And for right now, I'm just going to do like an occupied flag like we had before, meaning the point is. And then I'm going to put a v3 in here that's also a product of the collision detection that just says like the repulsion, right? So this is basically just a vector that points in that direction. So what I want to do is take collides at P, and I want it to produce one of these collision fields. So the result now is going to be about occupation in this way. We're going to remove this break statement here because we now need to do some summing up of the occupied colliders. But otherwise, that's all we're going to do. And then here, what I'm going to do is take this code that was previously calling it, and I'm just going to reduce it to just doing exactly what it was doing before by pulling out only the occupied field. Which means now we should run the game and get identical behavior to what we were getting before with no changes because the code is the same. I can still push into that wall just fine, and so on. Then what I want to do is say, okay, when we get this embedded situation here, and then we see that we are embedded, what I want to do is I want to change, and you can see out here we set up these best things here, right? Distance squared and all that stuff, right? So what I'd like to do is say, well, maybe I'm going to go back here. And I'm going to take this, well, I'm not quite sure yet, so let me hold off on that thought. So what I want to do here is say, like, okay, if I was embedded, and I want to turn this stuff on, what I might do is just say, okay, I'm going to clear out the occupied stuff so that you can move in a direction, but maybe then I'm also going to clip the motion direction to have to go in the same direction as the repulsion field, right? So, this is, I feel like it's not worth me going over to the light board just for this, but this is a very, like, diagrammatical sort of thing. So I have two vectors. One of them is the motion vector that says I want to go from here to here. And you can see that that's just, you know, a from P to P thing where I say this is the entity position and I want to go to this, I want to go this displacement. So then I end up with this new target is, you know, is that displacement, right? So that's pretty easy to understand. But what we're doing here is we're saying, okay, if we end up in a situation where we start off embedded, which is what's going to happen here, and this pretty much only is ever going to happen continuously or not at all, meaning either we're going to start embedded and then we may have some series of cells we traverse where we're embedded, or we start unembedded and we will never traverse an embedded cell because we wouldn't be able to move into it in the first place, right? So we know we start off with this being something that only happens from the very first cell and then may continue onward, but we know it's never going to happen like in the middle of a series of cells. Like we're never going to be like unembedded, unembedded, embedded, unembedded, embedded, right? It's either a series of embeddeds and then unembedded or a series of unembedded. That's all we've got. If something else happened, then the routine's gone haywire and we need to debug it, right? So we know that in normal operation with no bugs, that will not happen. So what we need to do here is say, look, if the thing was embedded, then we know that 2p, so the place that we're trying to move, we need that to be adjusted, right? We need to adjust the place that we're going to say, we're allowing you to do motion in embedded space. We will not allow you to go hog wild. We are only going to allow you to move it in the direction that would make it most closely resemble a removal motion, an unembedding motion, right? And so in order to do that, we would need to say, look, we know that the movement, right? So this best 2p here. We know that the movement, which I want to say we don't really care. So when this happens, we know that we have our from direction, right? And we now want to take and apply that delta to it. We want that delta to now be effectively clipped. Like, we want to clip that delta so that any motion that isn't in the same direction that would go against the direction of unembedding is removed. And I mean, I guess another way to think about this would be, do we want to just force it to go in the unembedded direction even if that's not the direction it was trying to go? And that's a good question. That's a good question, and I don't know the answer to that question, because there's a lot of different ways that we could play this, and I'm not sure which one is the smart way. Right? Like, one way to play this is that we just... I mean, there's so many ways to play this. We could actually not update 2p at all, and just update the occupied stuff in that direction. I might try that first. It's a really tough call, and I'm not sure. I really don't know. But like, so this basically is what I'm talking about. We would say, okay, so like if you're embedded in something, then what we're gonna do is we're gonna create some side values here for an unembed direction, right? And then what we're going to do is we're going to take and set that vertex, right? So that you can move in that direction. And maybe we could even do like, right? So we would say, okay, whatever side X we're on, this kind of thing. You know what I'm saying? So we're going to allow you to move out the unembed direction there. Maybe we allow you to move out of the face. We could take the strongest face and allow you to move out of that. In fact, that may be the best. Right, like I don't know, we have to sort of think about how we would want to code this efficiently, but you can imagine, like, you know, if unembed X is greater than unembed Y, you know, we're just basically picking the direction that's strongest. You know what I mean? And so then we could just say that we'll set these up in a specific way. So something like this. And so you can see it's like, okay, if X is greater than Y and X is greater than Z, then X is the face direction we're going to move out of, right? And so we would, in here, I guess we still need that side one, but so here we would just say, like, whatever the side X is, we use, and then everything else is just set, right? Similarly here, if we have a if we have X is greater than Y, but X is not greater than Z, then that means this would be the Z side. And then finally, we have the exact same case over here. So if this is not true, then that means Y is greater. I don't know why this is set up this way. So if Y is greater than Z, then we do the side Y one. And if it's not, then that means Z is the greater. So it's really just this case again, right? There's only 3 possible cases. We just can arrive at that same case in 2 different ways. So this one's the side Y case. And that's mostly what we want, right? So if we assume that this happens as well, where we just take a unembed direction, and we produce the side for that, and then we clear it. And again, we're gonna probably eventually need to think, oops, size, that's good. We're gonna need to think about how we want to do this maximally efficiently, because like a lot of this code is, you know, I'm just kind of sketching it out, just doing it directly. And I think that's roughly what we want, minus the spelling errors, right? So now all we need to do is actually produce that unembed value. And the unembed value, in this case, I will probably just take as a sum. So I'll probably just do unembed D here. I'll sum it up. So at each one of these things, we'll take the collision field and we'll actually record it. And then what I'll do is if the field oops, we actually want that. If the field is occupied, then I will take the unembed D and we will add to it. And there's sort of two ways we could do this. I think what I'd like to do is like embed count equals 0. So I'll count how many times I'm embedded here. I'll take the unembed D and I'll do the repulsion field addition here. And then when I'm at the end, embedded now will just be embed count. If the embed count equals 8, then you know they're all embedded. We don't need to study that any further. So this can just be directly placed in here. And then what we do is for the unembed D, we know that at that point, we need to normalize it. So it's had 8 things added to it, or well, I guess so. To be honest, we really don't need that. I mean, we know that we only use it in that one case. So actually, we can just do this, which is probably better because then it's not anything conditional. Ugh. All right. Well, anyway. So, point is, hey, we're only going to use this if all 8 were in, so that means we know we can just take the average by doing 1/8 times the value when we accumulate it, and then it's just known to be correct, right? It's just right at the time. So at that point, our main problem now, other than maybe logical errors we made in typing in that code, is that we don't actually set it, so it's always going to be 0, right? Which means that it'll just kind of let you move out of a random one of the faces, right? It's not really going to give any actual information. It's going to be, I don't remember how we wrote these ifs exactly, but it's going to be, all of these are going to be false. So it's going to be false, false. So it's basically going to say, look, you can move out of the Z positive face. So you can move upwards. It will always let you move upwards only. And then we also have to remove the else clause because now we're always going to still do the movement. So all we're doing is reconditioning the occupied checks to prevent you from going in a direction that you wouldn't normally be able to go, but that's the only thing we're changing. So if we run the code now, it should still work, and it should allow you to get unembedded in the upward direction, right? And so what that means is if I embed this in the wall like before, I wouldn't have expected it to do what it just did. Oh, but no, it kind of does. Notice it allows you to move in the upward cell. It looks like that's sort of what it did. Hard to say, though. So that may not be quite correct. let me see if I can get a better... So you know what? That is correct based on what I wrote. Okay, so that's a good piece of information I hadn't thought of. So if we do this conditioning, that means that you could still move like laterally, because if you, right, you would still be able to move laterally if you always considered those cells were out. So I do think this is a dumb idea. This won't, we do need to do the thing I said originally, which is condition the target vector. I think we do have to condition the target vector. So we have to adjust it so that it's pointing in the direction of unembedding. I think that's pretty much what we have to do. So I'm going to change. I'm not going to do that, like I said from before. Not going to do that. What I'm going to do instead, ignoring this. So that was a good piece of information, right? So I'm going to take this embed count here, and I'm going to say if it equals 8, then we're going to do the full wash, right? Like so. And that should be fine. So now you can move in all directions. And what we need to do now is say, okay, and when you get in this state, we are going to require that the place that you move to is going to have to be the unembed direction. Period. Right? So you have to move in that direction, and you don't get any choice in the matter. And we may say that, okay, we have a certain amount of distance here, because I don't know like what we actually want that to be. But we're gonna say that, like, for now, we're just gonna say it's you're trying to move 1 unit in that direction, right? Like that's where you're trying to get to. And what we probably want to do is we want to say, as soon as you get to a place where you're out again, we would stop doing that. Now, this is not, it's a little bit hard because I'm not sure. I mean, so I'm guessing I probably want to do this. Right? So try to get the person unembedded for a while. And if we do ever succeed in getting unembedded, then we revert back to trying to get towards the actual goal. Right? I could believe that. Okay. So this should do some weird stuff currently, because it's always going to have, well, no. So this will just freeze things in their tracks because that vector is 0, right? So things should not be able to move once they get embedded in something. If they get significantly embedded, they presumably couldn't move. Although weirdly enough, that does. So that's a little surprising. How is that able to move? So you would think, did I mess something up? You would think that this would mean that it wouldn't accept a motion here, because, oh no, it would though, because this hasn't been updated. Yeah. Interesting. So This seems very wasteful. This seems a bit wasteful, so I'm not thrilled about it. But it is what it is at the moment. So I think we're going to do it this way. So we may not really want to do that long term. But there we go. That's what I was expecting. Right? Like when I push this in like that, it should just get stuck. Right? And it should not be allowed to move at all, because it's supposed to be confined to moving to a vector that it literally is not allowed to move anywhere, right? It's like a zero vector of motion. So wanted to make sure that was working first before I interpreted what was going on. And now it is. So that's good. That's what I want. Good. Okay. So now what we want to do is actually produce this unembed vector that we are constraining to move by. And we just saw that it does kind of constrain the motion in the sense that if I make sure that this is 0, now you get physically stuck when you're embedded and you're not allowed to move anywhere, which is what I wanted to verify should happen. And so now what I want to do is actually produce the vector that I will allow you to move along. And so what you can see here is you can see that this collides at P. It's doing this intersection. It's taking the result occupied. What I want to do is be able to produce something here that represents the direction one would expect to have to go in order to exit the collision, this particular collision, right? And this will be a summation in that it will be like a sum of push directions, right? And whether I want to, like, how those should get normalized and such, that's a good question. We'll have to think about that in a little more detail later. For now, we just want to produce something. So we have rectangles, and we know that they intersect. If we've gotten into this part of the routine, we have two overlapping rectangles in space. We have the one that came from the thing that is moving, and we have the one that came from the obstacle. And what we want to know is what direction would we probably push these things in order to get us out of our current position, right? So with spheres, this is significantly simpler because you always know that the push is in the direction of the point, right? It's from the center to the point is always the shortest way out. And the problem with rectangles is that that's not true because if it was cube, it's sort of true because they're all have equal dimensions. So you can think of it as a sphere and it's probably roughly correct most of the time. But when you have something in an arbitrary rectangle, you have to remember like one of the three dimensions could be much larger than the others. So if you look at the vector from the center, it may have like a massively overweighted component that doesn't actually tell you what you wanted to know, which is what the simplest way to get out of there would be. And so that's a little bit harder. So I suspect what we want to do here is just say, how far in X, Y, and Z would I have to move to get to the edges? Right? You're always closer to one edge than the other. How far in X, Y, and Z would I have to move? And that is going to be the vector. Now, the nasty part about that is just that it's sort of a if statement festival, right? It's like there's a minimum and a maximum, and you have to go like whichever one is greater, right? Whether I take the negative motion, because there's two bounding planes to any kind of rectangular prism, and you got a point, and you want to know how far it is to the closest side. And so I'm trying to think, but I'm not really thinking of a good way. Oh, excuse me. In SIMD, this is actually not that hard, right? You could just do a test to produce the mask, and then you just do a select on the two. So, what is it, Booba? Oh, come up and just say hi, little puss. How you doing? What are you doing? What are you doing? What's going on? Do you want to do brushing times? Let's do brushing times. We're just working on the collision detector. It's coming along pretty good. We're just working on what we want our strategy to be for when the gameplay code creates interpenetrating objects. There you go. Coat health is very important. Isn't that right? Oh, we gotta trim your back nails. My goodness. They're getting way too sharp. All right. I got to finish this code here. Is that cool? I just want to finish. We've only got it. There's not much longer in the stream. I just wanted to just finish this one piece of code. Just with a sketch of something. Just to see how it works, Booba. Okay? How's that? How's that sound? Does that sound okay? Does that sound good? You can type it for me if you want. I know you like to type on the keyboard. You definitely have some interesting code that you've put in the past. I've experienced some very interesting cat code. New algorithms that mostly include repeating a single letter for a long time. Oftentimes the spacebar is involved. All right. Is that okay? Can I put you on the floor now? Can I put you on the floor? You can go around. Yeah? Okay. Come on. Go on. Go on, Booba. All right. Okay, then. So yeah, like what I mostly just want to figure out here is like what this directional thing would be here. And really, so like, you know, let's just do this for now. It's not great, but this is what I'm going to do. So, I'm just going to take an average count. The number of times we occupy here, we're going to increase the average count. And then I'm just going to do like an if average count result dot repulsion times equals 1 over average count. Right, so I'm just going to go in here and track this repulsion value by summing up some, like, unembed direction here like we were doing before. The unembed direction is just going to be, like, the center of, like, the Minkowski sum, maybe of these two colliders. So, or I could just, actually for now, we could do it even simpler just because we're pretty much out of time. So what I could do is just say, like, okay, let's just take the two collision volumes and subtract their centers, right? So, the test rect and the mover rect. So we want to say that, so if we were moving into it, we want to basically move towards us and away from them. So we want to go like, okay, we want to move towards the mover rect away from the test rect is probably what we're looking for. This is not good. We probably don't want this to be the permanent thing at all, but then at least we've got something we can start with, right? So that's the basic thing that we'll use. So going into next weekend, we can start to work with that, right? And so that looked a little odd, although it kind of works. Notice how it pops it right up on top there if it was high, and it keeps it out if it was in. So that actually does exactly what you would think it would do, actually, right? If it was up high, it will push it up higher to get over the top of that thing. Because there's nowhere it can go, right? You can't push in. So, I mean, even just that really stupid piece of code worked. If we put a ceiling on here, then it would just work, it looks like. So we may just luck out and not have to do anything fancy. We may just end up with something really stupid. It's fine, right? And the only thing we need to do here is make sure we have an actual cap on the ceiling so that you can't go arbitrarily high and go over walls, right? And that's just adding a collider at the top of the room, right? That's nothing. That's really simple. So I think that's good, and I'm happy with that for today. That looks great. Yeah, it just pops right up over the wall to avoid getting embedded. So, yeah, in pretty good shape. Yeah, no real complaints so far. Looks pretty good. And mainly the controller for the glove kind of sucks right now, so that is something we'll have to work on for sure. Although it kind of feels fun to play with, so maybe it doesn't suck that bad. So, we want to work on that, and also I think we want it, like I said, to be a sphere. All right, that's a pretty reasonable place to stop for today. Anyone have any questions about the collision detection? I can take a look at them. And while we are doing that, I wanted to show off something I just received in the mail. Check it out. So this guy, I don't know, it seems to be like really aggressively not wanting to autofocus. There it goes. So this guy is a UC1 from Grim Audio, and they sent it to me because I guess they decided they asked for permission about a year ago to use some Handmade Hero code stuff in their, I guess, the driver for the interface for the driver, or I don't know if maybe it was interface for this has a little screen on it. I don't actually know. But I was like, sure. Can you send us one when you ship it? and they graciously said yes. And so it's a pretty cool box. I have literally not read the manual yet, but it has like a crap ton of audio on the back. So it's basically like a ton of inputs and outputs. And I guess the idea behind it is that it's like a little like virtual kind of like routing sort of thing. Like, in other words, you can plug in a bunch of inputs and outputs and then use this thing to control like where things go, right? And honestly, like, having had a lot of problems with the stupid stereo mix crap in Windows, I'm kind of wondering if I can, like, once I go read how it actually works and stuff, I'm wondering if maybe it's something I could actually use on the show to get a more stable scenario, like a more stable like input-output scenario for the machine, right? So, you know, we've had a lot of problems with that in the past. We might want to try, but you know, that's about it. JS Chris brought up a question. What about tracking a previous location and always moving back towards where the entity came from? Yeah, that doesn't really work particularly well. And the reason that doesn't work particularly well is because all the entities are moving. And so there's no particular reason to suspect that the place the entity came from is any better than anywhere else, right? So what you really want is something that is so if we wanted to do this full all the way, right? What we would probably do is say, okay, let's just start searching in a radius and see where the closest place we could put this as unembedded is, right? That's probably the best thing. Then if we want to go a stage above that, you can have your room regions coded by reachability and only pick a location that has the same reachability as the last place the player was, right? And you can do all that stuff. In our case, it's probably not going to be very important to do any of that stuff. You know, this isn't The Witness or something where I cared a lot about trying to make sure that the player's experience was rock solid and it was supposed to be that way for game design reasons and all this other stuff. This is a very chaotic room-based hopping game with crazy crap happening. And so I don't care that much about those same sorts of things, right? So I don't think I would bother with reachability analysis. It just doesn't seem like it was a good use of time. What was the name of the audio box? It's called a Grim Audio UC1. So it is... let us open up Microsoft's amazing browser. Grim UC1. So it is this, and you can see like it's got like a bunch of output and input options, right? And because I don't know very much about it, I really, like I said, don't know if it's an appropriate thing for anything that we happen to do with the stream. But we obviously could use a nice like mixing and routing thing for any number of reasons, because of like all the trouble I've had with like getting audio to both go to headphones and to the other computer and all this other sorts of stuff, right? And so I don't really know, like, I don't really know. We have to play with it and find out. The reason I have one is because they use the Handmade Hero code. That's it. But And so I was just like, thought it was cool, but also it may end up being something I can actually use because it happens to be something that is in a space that we have trouble with, right? So it may actually be something that ends up being useful. Plus, knowing the people who worked on it means that if there's problems with the drivers or something, I actually have someone to talk to, which is different than most things I use, right? I could be like, hey, I'm having trouble getting this to work, or it seems to be blue screening in this case, or something, right? It's like sometimes it's nice to have friends who work on a device you use, because if you have a problem, someone might actually listen to you, which is different than, you know, the normal situation. Someone who started the series a few days ago and wants to make a game of his own. How do I manage to catch up with the current stage? I don't really think you need to, right? I would just say, you know, Handmade here is a good thing to watch to see the parts that you think that you need to see for working on whatever you're working on. But you can safely ignore the episodes that aren't about those things, right? And if you go to the episode guide here, this is such a weird episode. I don't know. I don't do this. It's a very strange program. I didn't make it. So it kind of is its own thing. It's just full nuts. There we go. You can usually do stuff like search for things in here that you need to find. Like if you need to know how to do SSE or something, or, you know, SIMD or something, you can look it up in here. But yeah, I don't know. It's so basically all the episode guide really needs to be good is some work on styles, right? Like you never want, like you see how small that text is? You never ever want your text to be a fixed size. Text should always be related to the rem size of the page so that it grows as the page grows and such, you know. So it doesn't make a lot of sense the way that it's set up at the moment. But like the actual content is very good. So, you know, you click on something, it goes right to that something, and then you get the...
So all of those things...
You know where it is in the video, right? And so it's pretty good. And you can play...
actually part of that that's...
through it and whatever,
and, so
and it keeps the stuff synced, so like on the side.
I need to produce a few things. Yeah. I need, first of all, the color, which
stylistic, like layout-wise, it doesn't really work, right? It's pretty busted.
Starting box
but
area.
Content-wise, it does.
Then what I need to do is,
and like I said, I don't really do it, so I can't. Really say much about it other than like that's what it is. I don't have time to go mess with this stuff, so but the content in it is very good, right? I recently discovered your stream. I learned a lot from the in-depth videos on how a computer actually works on a fundamental level, like the C tutorial and the Blackboard videos. I'm really excited about Star Code Galaxy. Do you have any information about when it will launch and what kind of material it will cover? I don't really. I mean, it will launch as soon as possible, but there's just a tremendous amount of work involved in it. And it's a very complex product to try and ship. So, you know, I promised that I'll put out an early access version before it's really ready. So I will be shipping it, you know, prematurely because people really want to get their hands on it. So there will be a sort of quiet early release that will be available to people. If you signed up for the mailing list on starcodegalaxy.com, you'll get notified when that's available. So there will be that thing. And I you know, I'm trying to get it out as soon as possible. Like literally as soon as I feel like everything is stable enough and there's enough content in it to release, we will. But it's a very complicated project that was done in a very small amount of time. compared to how much stuff is in there. It included building 2 studio setups at my house, a complete new design for an educational system, a complete deployment of that in JavaScript so it will run on the web, all the videos, the code base, like basically 3 complete game code bases. Like, it's a tremendously large thing that is very intricate and complicated, and I've had to do a tremendous amount of work to bring it to fruition. And so I other than the fact that I'm trying as hard as I can to get something out early, I cannot really promise anything else. Can you tease just how awesome sauce the SCG player will be? I mean, no. I don't know. I guess what I would say about the SCG player is you can look at it in one of 2 ways. One way is you can think of it as it is completely revolutionary and completely changes everything you know about how you would make course materials. Another way would be, actually, it's just the obvious thing you would do if you weren't YouTube, right? If anyone at YouTube cared at all about what watching things should be like when there's a computer, this is just what you would get, right? So, I mean, you can either do the, like, Paul Graham, an obvious thing is a revolutionary technology nonsense puff piece about it if you want, or you can just be like, oh, cool, somebody who actually cared made a thing for playing back videos for instructional purposes, and we got all of the things that you would think you would do are actually got done, right? So you know, it's there's a fair number of things in there, I guess, that maybe people wouldn't think of because they haven't gone and tried. Right? So there's a bunch of things that probably will be surprising, but when you see them, I think you will mostly think, oh, right, that's how it should be. I don't think you will think like, whoa, that's weird, or whoa, that's so far out there. I think you'll be like, oh, right, of course we should have done that. Right? So hopefully the things, I think there's a lot of really smart stuff in there, but I think it's all stuff that in hindsight, after you see it, it will seem very natural. It'll be like, of course we should have done that, right? Which is usually, I think, you know, the kind of idea I like. Have you implemented some kind of friction effect for the player walks or runs along the voxel boxes? Well, there's no... So in this game, things hop, so there's no real friction. So I'm not sure... There's only 2 types of objects in the system. Ones are hoppers, which just hop around, and the others are gliding, so they don't really do friction. They're just allowed to go anywhere they're allowed to go. So we don't really have a use case for friction in this particular game. Did you make the final products for each module first and then build the course around each for each module? Yes. I mean, to a first approximation. I guess that's not entirely true, but that's mostly true, yes. Can you explain again how the unembedded vector is calculated? Yes. So right now, it's not calculated in any particularly smart way. So right now, all we do is say, look, if 2 things are colliding, we just take the centers of each of their bounding boxes, and we assume that the thing that will get you unembedded is the opposite motion of that, right? So if two things, you take their two centers and you use the vector that would push back towards the person who's moving, right? So you have one person moving and one person who's stationary for purposes of this algorithm, right? The person who's moving, we basically push you back towards that person along the line of the two bounding box centers, right? And if there's more than one thing it collides with, we just average them. So it's not a very good, it's not good, right? It's not a particularly good computation, but it's fine for our purposes already, seem to work okay. So we may not want to belabor the point until we actually have some examples of it failing to do what we want. Any idea on the approximate price of Starker Galaxy? Yeah, so I haven't announced any final pricing yet, but the estimate was it would be like $50 per, per module, right? So $200 is for, so there's people who wanted to do like a buy everything. So $200 it was the price point that was floated for like you get all the modules, right? So the idea was that you can buy the modules are fairly substantial, and you only buy as many as you wanted to take, right? And those would be $50 per, right? So that was kind of the general idea, and the reason for that pricing was like it's basically like the price of a game, right? So it was meant to be kept around what people generally were used to paying for non-educational stuff, just to keep it more in line with standard pricing. So the $200 thing was like if you bought like basically like an umbrella package, right? Something that had all the modules in it. So that was more of a like special, like a Kickstarter tier kind of a thing. It's like, oh, the 200 one has like all the stuff and maybe some bonus content or early access to everything. So, if you buy the $200 one, you get stuff early before it's actually bundled into a module, that kind of thing. My friend started working as a C++ programmer, and he showed me the code base he has to work with, and it was a jungle of classes, templates, std::. It was very slow to compile. Is this a common thing in the industry to have this kind of code base? I guess that is why software is of bad quality. Pretty much yes. So bad programming practices, such as using the std library, which is a terrible library. No one should ever use it for anything. It's bad across the board. It's bad at everything. There are no good parts of std. It's just bad. Most of C++ is bad, so classes and templates. Templates are okay in light usage sometimes, but they're pretty bad in general just as a design. Classes are always bad, assuming that you're actually talking about things that were induced with classes. Structs and classes have no real actual difference between them. It's only if you start using things like virtual, private, those sorts of things, also all bad, right? But that's the typical way that large code bases these days are programmed, and the reason for that is not because they make large code bases better. They actually make large code bases worse, like the compile time, like you said. But rather that the prevailing dogma is that these things are good. So if you have a large code base, that means you have a large number of programmers, which means the majority of them will be subscribing to that dogma and checking in garbage like that. So it's kind of unavoidable because any large code base will, by default, reflect the current day's dogma, whether that dogma is good or bad. It is also then, oddly enough, reflexively used as a way to justify it. It's like, well, big code bases are written this way, so it must be about scaling. It's like, no, that's dogma scaling. it's too hard to hire enough programmers who don't believe the current zeitgeist to do anything different. What you're seeing is a political effect, not a programming effect. But, you know, again, that's just... Is SCG your full-time occupation nowadays? Yes, nowadays. I've basically had to convert to doing it full-time because I really need to get it done and out so I can move on. So, you know. Do you think putting completed Star Code Galaxy on a resume will be valuable? Gosh. That probably will depend entirely on how well it manages to reach sort of a wider audience. So I really don't know. Would it be easy to show someone in the industry who sticks to those beliefs that cutting off most of the C++ BS is beneficial? No, it's not easy. And the reason why it's not easy is because, as far as I can tell, people don't hold those beliefs rationally. They hold them irrationally, right? So nobody who uses STD has ever done any tests to determine whether STD was a good thing. They never tested compile time. They never tested performance. They never tested scalability. They never tested anything, right? They just used it because it was standard. So it's very hard to convince them to not do it because they didn't base their decision to use it on any actual science to begin with. So what are you going to do, right? So some people who just did that non-thinkingly, and then when you say, hey, we should think about this, maybe they're like, oh, yeah, we should. Those people will probably be reachable pretty easily. But everyone else is just going on dogma anyway. So what are you going to say? They're not going to be like, oh, I'm suddenly interested in actually evaluating this thing. Because they wouldn't have used it if they were, right? I mean, another way to say that would be if you asked most people why they use a lot of these practices, they don't have a science-based answer for you. Like, they don't have an answer that, like, we evaluated these things and here were some metrics we used. Compile time, performance, executable size, bug count, none of that stuff. So if you don't fundamentally have a science-based answer as to why you did do something, it's pretty hard to imagine how you would convince someone scientifically to stop doing that thing, because that's obviously not how their brain works. Like, they obviously aren't making decisions based on metrics, so what are you going to show them, right? What I think you would have to do is just change the zeitgeist. Like, you have to change the dogma first, because they're the kinds of people who will just go along with whatever the industry dogma is. So you'd probably have a much better likelihood of succeeding by changing the dogma over time, rather than trying to change particular people who are dogma followers to stop them from following dogma, right? I mean, and maybe you could, but then what you're really doing is just making them follow your dogma. But you haven't really fixed the situation that well, necessarily, still, because they're still just doing a dogmatic thing, right? They're not actually evaluating. So I don't know. Like, I don't know that there's that much resolution. I think this sort of thing just happens the way it happens, right? I use some templates in my C++ code to avoid large amounts of code duplication, but I struggle with compile times. Could you recommend any material on metaprogramming in C++ you think is good? No, no. I mean, this is why I say, like, C++ just sucks. It's a crap language. The reason I don't use templates is not because I don't want metaprogramming. It's because it's just a bad language for metaprogramming. So you're just kind of screwed. Like there's a lot of metaprogramming stuff you would want to do. Templates are very bad at it. first of all, they make it unnecessarily difficult to do what you want to do, and then second, the compile times are terrible. Yeah. Oftentimes, the error messages are also terrible. Do you used to use standard libs and then switch to the Handmade style? Yeah, so I kind of like bounced over or like boomeranged through it. So I used to program basically this way. I did some programming with C++ for a while, so like inheritance hierarchies and templates and crap. And then I like actually evaluated all of them at a project at Rad. I was basically like, okay, we're going to try like seeing how the code comes out by like using and not using these various things. And what I determined that basically like the only things that I thought C++ had added that were useful were operator overloading for math operations, which I do think is a good idea. It makes the code much more legible and can be compiled relatively cleanly. And the other thing was declare anywhere, which C now also has. But that's it. So inheritance, not good. I wouldn't recommend it. Templates have some benefits, but the costs outweigh the benefits, so also not good on the whole. The newer things in C, so like lambdas, or like auto, were not around at the time. So something like auto is probably fine, would be my guess, because it doesn't really do anything. It's just a simpler shorthand for not having to type in a type, when the type would obviously be known. So I would have a hard time believing auto isn't fine to use, but it wasn't in the set of things I tested at that time because it didn't exist yet. Smart pointers are garbage. There's no need for them, for sure. Declare anywhere is just the fact that, so in the original versions of C, all of the variables for the function had to be declared at the top of the scope. And you could make a new scope and declare functions at the top of the scope, but you could never declare, like you couldn't do like int a equals 5, a times equals 2, int b equals 4. Because there was an expression in between two declarations that was illegal. All the declarations had to come at the top, right? And that's just kind of annoying. Like, there's really no good explanation for why you would need that. It doesn't really do much for you. Maybe there's some arguments about it enforces good programmer, discipline or something. But, like, I don't tend to like arguments like that. Like, I don't tend to like arguments that are like, the reason we do this is because it results in a good programming practice. Like, I'll decide what the good programming practices are, thank you. What I want from the language is the ability for me to take programming practices that I think are good and do them. I don't want you to decide that because I'm pretty sure you don't know better than I do what the good programming practices are for my project, right? So basically, like, would you recommend Rust over C++? I mean, I haven't really used Rust. Probably not. Rust seems like a pretty bad language to me. I don't understand why people think it's good. Well, I kind of maybe understand why people think it's good. I think those thoughts are misguided. But, so no. I mean, it's 6 of one, half dozen of the other, though. Like, if you look at Rust versus C++, like, they're both, I think, languages that aren't designed very well. But they probably, if we really want to start nitpicking, there's probably, like, a similar number of things done poorly versus done well. So I doubt, I also wouldn't tell you to definitely use C++ over Rust or something. I think they're both lousy languages. So I'm not gonna get in an argument about which one is better because I A, don't care, and B, don't know that you could make a particularly coherent argument either way. Given that Handmade Hero is running for quite a while, doesn't it seem unfeasible for solo indie devs to go with a custom engine, especially since you're more experienced? I mean, I don't know. Like, probably not. at all. I mean, Handmade Hero has not even completed a single year of programming yet. Right? We haven't even spent a year on this engine yet. If you add up the hours, even including the explanation time, right? We haven't even gotten to a full-time year of programming yet. So, and we have a crap ton of stuff in the engine. So we haven't even gotten to a year yet. I don't even know what we're at. But it's probably not a full year if you actually tried to count the hours, right? You assume you program like 40 hours a week, 30 hours a week, something like that. Right. So. I mean, I should also say, like, kind of separately, like, one thing that I definitely think, like, perspective-wise is I literally don't care either, right? So one way to look at it is, like I don't care what people want to do or don't want to do. Meaning, like, someone who wants to do solo indie development, they should do whatever they want, right? I don't care at all. Yeah, I could vaguely try to, you know, analyze your choices for you. And you know, I don't know, but I don't care. Like, to me, programming is about the fact that I like programming. It's not about business, you know? I'm not a business person. I'm not here to tell you how to maximize your returns or something, right? So asking me, like, what you should use for an engine is really not that useful. So at this point, I tend to just tell people, like, I literally don't care. Like, it's not really my thing. I don't care at all about what you use. If I had to guess, I would say you probably want to use the Unreal Engine or Game Maker. From what I've seen, you know, I'd probably say that's what you would do. If you aren't going to roll your own, I'd use one of those. Wouldn't probably use Unity. I think Unity's probably headed for a... I would say Unity is not long for this world. Like, if you look at their company's financials, they're a publicly traded company now. Their financials aren't good. They don't make money on selling tools to game developers. They make money on ads, on advertising and such. So I think putting, I would bail from Unity as soon as you possibly can. That'd be my, like, vague looking at reading the tarot, you know, cards, reading the tea leaves. I would say bail from Unity as soon as you can and build a pipeline based on something else. That something else doesn't have to be your own, right? Like it doesn't have to be your code base. It could be the Unreal Engine, which I think will be very stable. They make a crap ton of money. They make, like, infinite money. They're not going anywhere, and their entire revenue stream is basically built off of game stuff, right? So maybe Unreal Engine. It's also in a lot of high-end stuff, so that's fine. So I might think about that. You could think about just a smaller scoped tool. So, you know, if you get away with something like Game Maker, a lot of people have a lot of positive things to say about that. A lot of games I play in Game Maker seem to run pretty well, unlike Unity. Unity games, oftentimes, unless they're done by people who really know what they're doing, who clean up a lot of Unity garbage, they often play really crappy. They're either slow, buggy, messy. They're, like, you know... Game Maker doesn't feel that way. Game Maker feels pretty solid. A lot of times I play Game Maker, it feels pretty solid, right? So I would say look at Game Maker, look at Unreal. I think those would be potentially reasonable things to base, you know, your engines off of, whatever you're doing. I think at this point I would strongly advise against Unity. I don't see that going positively in the long run. I don't have enough insight into some of the new things. Like, there's the Godot engine. People have been working on that. There's, like, other engines that were, like, I don't even remember what they all are, but there's, like, other engines out there I just don't have any insight into. But that's your decision, and I don't care. Use whatever you want. That's just my basic thing. And I can't really tell you what's the right decision for you. I like programming, so I'm probably never going to ship something ever that's not on something that I wrote, whether it's a game or otherwise. It's just not what I do. and I don't care. I'd rather fail to ship a game on my own engine than succeed in shipping it on someone else's, because I don't prioritize that, right? I don't enjoy using engines. So I would, if I was going to do that, I would just go do something that made money, just purely to make money, right? I'd go do a web startup or something and just try to rake in the cash if I was going to do that. I wouldn't say what's the most economically feasible way to make this game, because to me that just doesn't interest me. I don't care about that at all. And so that's really not something I can make much of a recommendation on. So yeah. So my only recommendations is what I just said. And that's based solely on just looking at what I would anticipate Unity's future to be, and I just don't see there being one for games. I don't see that being likely, right? But I do think you will have options. Game Maker and Unreal seem like solid options for the future to me. The problems with Unreal Engine are that it's like this massively overcomplicated, sprawling mess, right? So, you want to make this game that's pretty simple because you're an indie dev, and here comes this gigantic code base that people use for shipping gigantic AAA titles, right? So, I can appreciate that. That's why I always try to say, like some stuff like Game Maker seems pretty solid if you just want to work on a game. You don't want to think about coding. You don't want to think about engines and stuff. I would say, like, if you can get away with like a 2D, like doing a 2D platformer kind of a thing is in your wheelhouse, take a look at Game Maker, because it just seems like it's the kind of thing that's easy to get running quickly, and it produces a pretty quality product at the end of the day, reasonably, in my opinion. Unreal Engine is obviously just massive and sprawling and is probably more technical expertise than you want to really take on as an indie dev. But, if you're trying to do a 3D thing, I don't know what other option. I really don't think it's solid to base your future on a Unity-based engine. I think it's a huge mistake these days. I really think it's a huge mistake. If you keep your Unreal game to just stuff achievable in Blueprint, it seems pretty accessible. If you want to do C++ code, then it's very nuts. Yeah, that could be true. Like if you're just trying to make like a skin on a first-person shooter, like kind of all that stuff's like already in there, right? And so I could easily see like there being certain tranches of games where it's like, okay, Unreal Engine is pretty easy for us to use. We just kind of run the pre-built executables. We don't really program anything in C. We use Blueprint to just do some light like game logic on top, and that's the game, or it's like a walking simulator. It's like Firewatch or something, right? It seems like you could just do that, right? Because there's no game in the game. It's just we walk around environments and we trigger some sound effects, and that's the game. Like, you probably nowadays could get away with like no programming, basically, like just some graphs and Blueprint, I would imagine would get you where you need to go. So again, like some things to think about are like what are the actual technical requirements for this game, and can we get away with not really doing anything? Might be true. There's plenty of games that are that way. So again, really don't know, and don't care. Like, I really don't care what people do. I'm only interested in people who want to learn to program engine code, and I want to show them how to do it. I don't care about people who don't want to make engine code. They should go not make engine code, right? And I'm definitely not interested in trying to convince people to do something else. Like they should do whatever they want, All right. All right. Thank you, everyone, for joining me for the episode of Handmade Hero. It's a pleasure coding with you, as always. If you would like to follow the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can follow along with it. We got better results today than I was expecting, so I guess I don't even really know next week if we will keep working on the collision detector. That might actually be sufficient for pretty much most of our development. That seemed pretty solid, collision detection wise. So next weekend we might stop working on that. The only thing we might do is introduce a spatial partition so that the collision detector will scale better. Right now it's literally checking all the entities in the active set, all of them, every time it does that collision check, which is way too many entities. Computers are crazy fast. It's insane that it runs real time like it does. Especially when you open up a web page and the thing can barely run. What can I say? So that probably should get handled. We probably should put in a spatial partition just to keep that under control. I think we don't want to have this thing where we start adding a bunch of entities to the world and then the collision detector becomes a bottleneck. So we should just put a spatial partition to keep it like nice and O1 style cost. And then, so I think that's probably what I'd do next weekend, and then we'll move on to just gameplay, glove programming and fighting, to try and make some enemies that are fun to engage with the glove, which is the reason we built the collision detector in the first place. So we'll try to do that, and come up with how we want that to work. We'll work on that. And so next weekend, Space Partition, weekend after that, doing some stuff with like collision response. What happens when you hit somebody with the glove? How do we want the glove control to work? Do we want like entities to be like pushed by the glove and things like that? So now that we have a collision detector, what do we actually do with the information we get back from the collision detector besides just keeping things from going into other things? What do we actually want the results of those collisions to be in a gameplay logic sense is what we'll do after that. So that's the roadmap going forward. Hope to see you back here for that. Until then, have fun programming, everyone, and I'll see you all on the internet, and so on. So take it easy, everybody.